Every planet spins, every star spins, and every galaxy spirals, and yet no one told the universe to start moving. So why does everything, from atoms to entire galaxies, seem caught in this endless cosmic whirl? Imagine pressing pause on time, freezing the universe for a single instant. You'd still see Jupiter rotating once every 10 hours, Earth turning beneath your feet at over 1,000 miles per hour, and the Milky Way rotating around its center at more than 500,000 miles per hour. Even space itself, the very fabric of reality, might be rotating on scales so large we can barely detect it. But what started this motion, and why hasn't it stopped? This is Tomorrow Explained. I'm Dennis, a designer, researcher, and storyteller exploring the forces shaping our world and the worlds beyond it. Every week, we break down the science and ideas that reveal where we're headed next. To understand why the universe spins, we have to go back to the beginning. Not the Big Bang itself, but the tiny quantum fluctuations before it. In the first fractions of a second, energy and matter were not evenly spread out. There were small, random ripples, tiny differences in density. Those slight imbalances created the seeds of every galaxy, star, and planet that would ever exist. As gravity pulled matter together, those ripples began to swirl. And once things started moving, they kept moving. That's because of one of physics's most beautiful rules, the conservation of angular momentum. It says that if something starts spinning and no outside force acts on it, it'll keep spinning forever. You can see this law in action every time a figure skater pulls their arms in. Their spin speeds up because their mass is now closer to their center. Planets form the same way. Billions of years ago, clouds of gas and dust began collapsing under gravity. As they shrank, they spun faster and faster, like cosmic skaters pulling their arms in. Those spinning disks became stars, and within them, smaller eddies of gas and rock formed planets, each carrying a piece of that original spin. That's why Earth rotates. It's not something it learned to do, it's something it inherited. The same principle scales up. Our entire solar system spins around the center of the Milky Way, completing a full orbit every 230 million years. And the Milky Way itself is spinning inside a vast cosmic web of other galaxies, each rotating, colliding, and merging in slow motion over billions of years. But here's the strange part. When astronomers measured how fast galaxies spin, the math didn't add up. There wasn't enough visible matter to hold them together. The stars on the edges were moving too fast. They should have flown apart. That mystery led to the discovery of something unseen yet massive, dark matter. Invisible, undetectable, except through gravity, it acts like cosmic glue, keeping galaxies spinning in defiance of physics we can see. So the spin of galaxies doesn't just reveal motion, it reveals mystery. It's how we first realized that most of the universe is made of something we still don't understand. But does this rotation go even deeper? Some cosmologists think so. Recent studies using the cosmic microwave background, the afterglow of the Big Bang, hint that the universe might have a preferred direction, a faint cosmic axis. If true, it could mean the entire universe is rotating on unimaginable scales. Not just galaxies or clusters, but space-time itself, twisting ever so slightly as it expands. It's still debated. Most models say the universe is isotropic. No preferred direction, no grand spin. But if the universe does rotate, even by a tiny fraction, it would change everything we know about cosmology. It would mean the universe isn't expanding evenly, it's spinning as it grows. A cosmic dance, not just a cosmic explosion. And maybe that makes sense, because everywhere we look, motion seems to win over stillness. From electrons orbiting nuclei, to planets circling suns, to galaxies spiraling through the dark, the universe seems to prefer movement over rest. Spin is stability, rotation creates balance. Without it, the forces that built everything we know might never have aligned at all. So the next time you look up at the stars or feel the faint pull of gravity beneath your feet, remember this. You're part of that same spin. The same ancient momentum that began at the dawn of time still turns through you, through the oceans, through the atoms in your hands. The universe didn't stop moving, and neither do we. This is Tomorrow Explained. If you enjoy exploring how science shapes our future and our place in the cosmos, subscribe and join me for more stories that make sense of tomorrow, today.